Truly, we can't change just because we're teaching virtually. In particular, I think our focus still has to be to build understanding, to focus on ideas and not just skills, and to meet the needs of a variety of kids who do have different needs. So, all of that I think needs to happen whether we're in a virtual environment or not. The other thing that I think is equally important is that kids love math and that kids love to think, and they think that learning and thinking are very positive things. In my mind, that's really what school's about anyway, to grow people who really believe learning is a good thing. So we have to find ways to do that in this environment, and I'm going to just share some thoughts I have. Um, One of the other thoughts I had was that when we're in a virtual environment, we are uniquely attached to the parents of our students. Even though we're all connected to the parents of our kids, especially when we're working in this way, the parents are the intermediaries between teachers and kids. And so I feel it's extremely important that parents, we use this opportunity to show them what we think math should look like because it's a great opportunity to do that. So I'm putting them in the package as well, and I'll talk about that a little bit more too. Now, I don't know what you know about me or what I do, but I can say that I am very focused on what I would call teaching for meaning. It's not like just listen to me and do it, it's like you understand. I'm very focused on meeting the needs of struggling learners and capable kids and kids who just can fly, and maybe addressing all of them, not just some of them. And I'm also very committed to concentrating on what I'm going to call the big ideas of math, because I think that when we make connections for kids through big ideas, it helps them enormously. So those things are going to be underscoring everything I'm going to show you today. And in particular, Joe mentioned that I'm going to talk about open questions, and I am, because I think that they're good all the time, but I think in this environment, they're particularly useful. What open questions are questions to which there are a lot of answers that make sense, and where kids can address their responses based on where they are in a learning trajectory, and that it will appeal to a broad range of kids because they can address it the way they see it. I think it leads to what I'm going to call rich mathematical conversations, and those could be online as well as in person. I do think they meet a lot of needs, and I also think that it tends to get a teacher to focus on more important stuff because you need a question that works for a broad range of kids. So you're going to see lots of examples, and here is number one. So the question is, when you count, what are some numbers that take a while to get to? So you're counting, and it just takes you a pretty long time to get somewhere. Where could that number be? I'm going to have you answer in a minute, but one of the things I'm going to mention is that when I'm doing things in a virtual environment, I try to do more visuals. What you see is a number line that goes from 0 to I don't know where, just to tell kids I'm thinking about getting somewhere on when I'm counting, where could I get? So somebody just type in the chat box, and maybe Joe can tell me what they're typing. What are some numbers that you think kids would say it takes them a while to get to?
Oh, I'm sorry. I think I was muted. I've seen 1,000,000 pop up a number of times. I've seen 1,000 pop up a number of times. 150 has popped up.
Beautiful.
I see a gazillion.
Okay, a gazillion is a good one. Okay, would anybody live with like 50? So that could be like a conversation you have with kids. And kids get to say whatever they want. If kids talk about gazillions, it's fun. You can talk about how big is a gazillion. If they say 1,000,000, you can say, well, how do you know it takes a long time to get to 1,000,000? And you could talk about that. The purpose of the question is for kids to see it depends on what you count by. Because I can get to 1,000,000 really fast if I counted by millions. 1,000,000, 2,000,000, 3,000,000. I got to 1,000,000 pretty fast. So the whole idea is that you're looking at a concept. The concept is that you get to numbers faster depending on what you count by. And this question allows kids to have fun. It allows them to think about whatever they want to think about counting. It gives you insight into what they're thinking, but at the same time, you get to bring an idea up. And it's a pretty simple kind of question. So here's another one. What number might the dot represent on this number line, and how sure are you? So I'll tell you why I'm asking the question, then I'll let you answer maybe a few answers. Notice that I didn't say what does it represent, because I don't think you can be sure, really. But you can be maybe pretty sure, and some of you will probably be more sure than others. So what number do you think the dot represents, and how sure are you? So a few of you just put in what number you think it is, and maybe just write pretty sure, not so sure.
17, 12, 17, no follow-ups yet. 15, okay. Pretty sure, 15, pretty sure.
Excellent.
13, 17, okay. Kind of sure, 11.
Thank you for participating, folks. And that's great. And notice that you all weren't that far away from each other. 15, 17 are pretty close. But on the other hand, you weren't all exactly the same. Now, do you see the difference between this question and one on a number line where all the ticks are there and all you do is count? This one's more interesting because I want kids to know that it's about the relative proportions. It's not about counting. So the reason I think most of you pick 15, if we were in a class and had more time, I'd get you to talk about it, is that I think you're seeing, oh, it looks like about a third of the way maybe, or something like that. And that's why you're picking 15. I would probably say to kids, well, how come you didn't pick 10? Or how come you didn't pick 30? And those would become the conversation that this leads to. So with open questions, it's not so much just the question, it's how you follow up with the kinds of answers kids give and what you say in response to their answers. Here's a different question, and this one is about patterns. And this says a repeating pattern, so that means that the items in the pattern repeat, starts like this. How could it continue? So one of the things I want you to notice, I didn't say how does it continue. I didn't show a whole bunch of copies of yellow and red. I just did one yellow, one red, and said how could it continue. So I want kids, I won't bug you on this one, I want kids to know that there's a lot of possibilities when you start a pattern to continue it. There is almost never, in fact, there is never just one continuation unless somebody tells you a rule, and I didn't tell you a rule. And so I want kids to know a whole bunch of things could happen. So it could be something simple like you were probably thinking, yellow, red, yellow, red, yellow, red. It could be yellow, red, red, yellow, red, red. So maybe it's not just yellow, red repeated, maybe other things happen. Or maybe there's even a green stuck in there and like that's okay too. So the purpose of that question is for kids to deal with the idea that if you don't have a rule, there's a lot of possible ways to continue a pattern. In fact, there's what we would call an infinite number of ways, but there's certainly a lot of ways, and we want kids to mess around with that. Do you see how different this is than the traditional question where we show yellow, red, yellow, red, yellow, red, yellow, red, and say what does come next instead of what might come next? So that's, again, an example of what's open. Now, I think this works virtually because you could be talking to kids even online and having this exact conversation. You could have these slides ready to go. If they come up, you can have, a lot of teachers I know are working on online whiteboards. There's one called Ziteboard that a lot of teachers are using that is free. And kids could just be drawing their shapes online. Here's another question that fits really kind of nicely in a home environment. So I'm showing you some Lego blocks to tell you I'm talking about building blocks, and I'm showing you a shoebox to tell you I'm talking about shoeboxes. And I'm asking you about how many building blocks fit inside a shoebox. Test your prediction. Would it be the same number even if you used a different size of block? So this would be not something you would do synchronously. You would give kids this question. You would ask them to kind of go away and work on it. And then you might have a short little meeting with them to say, well, what did you find out? And what did you find out? And how come Aaron's number was like so different than Tara's number? Why would he have like a huge number and she has such a tiny little number? And getting kids to focus on two things. One is it depends how big your shoebox is. And the other is it depends how big your block is. And those are big and important measurement concepts that both of those things play into measurement with a unit. What is the size of the unit? What is the size of the thing that I'm measuring? So you can see what I mean when I say that there's a concept like underneath all of these questions, that it could address the needs of a lot of kids, because any kid can get out a shoebox and stick blocks in there and count. But kids who are really curious might try different size blocks, and some kids won't. So it's addressing lots of needs, teaching important math, and generating a rich conversation. Here's a different kind of question, very number and straightforward. Show me 12 as two equal groups. Now, I just chose to visually show you 12. I just picked cylinders randomly. And what we'd expect kids to do is move these things around, or if it's not possible for them to move them around. So if you were teaching them, you could tell them at home, get out 12 paper clips and pretend they're my little cans. Or you could tell them to circle things on a slide, whatever it is that you want to do. Show 12 as two equal groups. And it helps kids see that one of the ways we can show 12 is as two equal groups. But there's other ways to show 12. Suppose I wanted you to show me that 12 is between 10 and 20. Doing the two equal groups isn't so great anymore, because that doesn't like super help me see it's between 10 and 20. Like, you still see it because you could count them all, but it's not obvious. So the idea I'm working on is that how you represent a number changes what you see about it. And so this time I'm saying I want to see it's between 10 and 20. Does anyone have any suggestions for how they might show that?
Robin suggests a group of 10 and two more.
Beautiful.
Anne says put 10 in a group. Angela suggests a group of 10 and two remainders. Jennifer suggests a group of 10.
Okay, so you're all making great and good suggestions, and that's what I did too. I made a group of 10 and two more. And one of the things I chose to do as a teacher is put it in the format of a 10 frame, because I think kids associate 10 frames with 10, two of them makes 20, three of them makes 30. And so they kind of like see the 10 in a 10 frame and two more. Now, that doesn't mean you got to do that or that a kid has to do that, but it's kind of a nice way for you as a teacher to show, oh, isn't that a nice way to see 10? Because like I know it's 10 right away. I could ask them to show me the 12 could be three equal groups, and we would just sort of circle groups of four. And I've even kind of arranged them in the picture, so that's not so hard. And that's a way of telling me that 12 is something that three people can share, which is something different. When I showed it as 10 and two more, it wasn't as obvious that 12 could be shared by three as it would be here. Or I could say, show me that 12 is less than 15, and you might go back to that 10 frame piece. So the idea I'm working on is that the way you represent a number tells you stuff about the number. So I picked 12 and 15 because those are fairly simple things. If I want to let some kids go higher, I'd say, you give us an idea of how we should show 12 that shows us something different about 12. And then kids could play around with that and come back together and talk about it. Here's a different kind of a question. This is what they used to call these attribute trains. And even when I was young, and I'm not anymore, this was quite popular, where what you would do is you would change one or two attributes going from one object or one picture to the next. And you'd have to decide what the next picture looks like. So look at my little people. Look at number 1 and number 2, and you can see two things changed. The flower changed and the mouth changed. Going from 2 to 3, 2 things changed. Going from 3 to 4, 2 things changed. So I asked the kids, what do you think could come next? And again, I use the word might because there's some possibilities. So somebody give us a shout out about what your next person would look like.
Corey says to change the shirt and the mouth. Karen says blue and red stripes, hair down.
Yeah.
Andrea suggests reverse the stripes and add feet.
Excellent. All right. So you're getting the picture, like you're grown-ups and you've come up with all kinds of ideas. Kids come up with even more ideas. And it's a way for you to talk about what attributes mean. We talk about attributes of shapes, but we want kids to know everything has attributes, not just shapes. And this is a great way to talk about that idea. And it's fun and it's interesting and it suits a broad range of learners. This is more, I'm going to call it straightforward, even though it's not, but it's a sort of a place value-y kind of a question. So my question is, if you were writing a number that was less than 1,000 and you were reading it to me, how many words would you need to read your number that's less than 1,000? What's the possibilities? Would you ever need, what's the most number of words you need? What's the fewest number of words you need? And notice I just threw a couple words up there to get kids started because I'm not with them to kind of walk over and chat with them. So I need to get them started. One of the dangers of writing these words is that kids will feel they have to use them. So you need to say, I gave you some ideas of words you might include, but you could use lots of other words. You don't have to use my words. So some of you think about how many numbers under 1,000 and tell me how many words you might need to write to read those numbers.
Karen says 1, Natasha says 1, Anne says 8.
Ooh. All right, so different people see different things. So I'm going to work with you. I think sometimes it's a one word, like if I'm reading 6, or I'm reading 30, or if I'm reading 80. Sometimes it's 2 words, if I'm reading 98, or 300. That's 2 words. Sometimes I need 3 words, like 408. Sometimes I need 4 words, 3,034. Sometimes I need 5 words. Oh, except 3,034 was illegal. Don't even look at that one, right? Sometimes I need 5 words, 922. So the whole idea is that kids are thinking about the place value system, how we read numbers, but it's kind of a fun task. Since I messed up the 4-word one, now you should be thinking, oh, I wonder if it's possible for there to be 4 words that you need. And the answer is it happens to be possible, but that's something to think about. And so this is kind of fun, and it gets kids thinking about important stuff, but in an interesting kind of a way, and it leads to a big conversation. Notice that it took 5 words to say 922. Oh, I screwed up again. That's 4 words. Okay, I need some help here. So 922 is 4 words. And so now you're worrying, well, could there actually be 5 words? And so those are good kind of questions. I'll fix this slide, by the way, before I post it. So that would be neat. Now, I mentioned that I want to meet the needs of all kids. And here a kid might say 3 2/3. Like, I'm not asking them to, but there's going to be a kid in the room or in the group who might say that. Or 6 24/100. Or -3. Now, I don't think most kids will say those words, but you're leaving what I'm going to call space for those more creative kids to come up with ideas as well. And I think that's just as important as lots of the other stuff we do. Creativity needs to be an important part of math, and these open questions often allow for that. Okay. One of the ways to create an open question is to use Jeopardy style questions. So here is my question to you. The answer is 312. So look in the numbers category. The answer is 312. You obviously get $1,000 if you say it right. What could your question be if the answer is 312? So type in a question. The answer is 312.
Joanne says, what is 300 plus 10 plus 2? Amanda says, what is 88 less than 400? Angeline, 412 minus 100.
Beautiful.
Robin, how many tacos I've eaten since quarantine started. Peter, what is 156 times 2? Jacqueline, 312 more. They're coming fast and furious. Karen, Jane has 300 candles. Bob gave her 12. How many does she have?
That's quick. All right. So
Okay, and others as well. Thank you to all.
great. So do you see what I think happens when you ask a boring question? A few kids raise their hand and the others just like wait for it to be over. And in a question like this, now I know you're teachers and you're more cooperative, but you get lots of responses and you get lots of participation and you get kids saying unusual things like the taco one. And it's such a happy environment, but you're still doing like important work. So if a kid said it's 2 times 156, I'm going to say, well, how do you know that? And then the kid will talk some more. Or if a kid said it was 300 plus 10 plus 2, what made you say that? And so we have lots and lots of math that can come out of a simple little question like that. We can meet the needs of all kinds of kids because a kid could say the question is, give me a number that starts with a 3. And that would actually be a totally okay question. So unlike Jeopardy, where there's only one right answer, there are lots of right answers here, but kids enjoy this kind of thing, and it's an easy way to create open questions. Another style of question which has become popular in the last couple of years is something called which one doesn't belong. And the idea of these questions is that you present, it's often 4, although there's no rule that it has to be 4, different things, and the kids have to decide how 3 of them belong together, but one of them just like doesn't go with the others. So it's kind of like Sesame Street, but on Sesame Street, when you say who doesn't belong or which one doesn't belong, there's a right answer. Here, there are actually multiple reasonable choices. So you look at those 4 multiplications and pick the one you think doesn't belong and tell us why.
Kelly says 5 times 21 because the solution is over 100. Dwayne says 5 times 21 because it is a multiple of 5. Robin, 4 times 23 because you're multiplying by an even single digit number. Peter, 3 by 33 because it uses all the same digits. Jacqueline, 3 times 33 because it only uses 3s. Mary, 3 by 33, joining one with same digits again. 4 by 23 as the smallest factor is an even number.
Excellent. Okay, beautiful. Now, when you create these as a teacher, you try to create them so that there are multiple answers, and you've already shown me there were. Lots of you picked the 4 times 23 because 4 was the only even single-digit number. The first person, I think, was Kelly, said 5 times 21 because that was the only response that was greater than 100. That was on purpose. A lot of you picked 3 times 33. Now, I might say nobody picked 7 times 14. Can you think of a reason? And that would be interesting to see if a kid could come up with a reason. Do you notice that 14 is the only even 2-digit number? So that was what was in my head when I created this, but they might have some other reason, like it's the only one that is something else. I think it's the only one whose digits add to 17 or some crazy thing like that. So getting kids to come up with reasons why they're different is great. One of the ways I think you can appeal to the different needs of different kids is for some kids, as long as they can come up with one idea and one reason, you're happy. But there might be some kids who are ready to think of a reason for absolutely every possibility. I wouldn't impose that on all kids, but I definitely would let some kids go there. And then I'm doing that differentiation piece. I'm meeting the needs of lots of different kids. So these ones are great. If you didn't know, there is a website, WODB.ca, which one doesn't belong.ca, which has tons of these for many different levels. Some of them will scare you because they're for high school, but there's lots of these around. Here's another kind of a question. I have a number line again. I am using the number line a fair bit because it is a crucially important tool in elementary math. And so using it a lot is a good thing to do. In this particular case, you can see that I'm showing jumps on the number line. I'm going to tell kids, you can see that the jumps aren't the same size, are they? They look like they're getting, what do you think? A little bigger, a little smaller? Hopefully kids would tell me they're getting a little bigger. And what did I tell you and what didn't I tell you? I would ask the kids. So I want them to realize I didn't tell you where to start. I didn't tell you how big any of the jump sizes were, but I did tell you that you're going to where 200 is. And obviously you started before 200. So that much I've told you. So the question is, how many jumps would it take you to pass 200? If the jumps are getting bigger, I didn't tell you where you started and all that kind of stuff. Now, do you get how much conversation you can have? If a kid starts back at 1 and their jumps are 1 and then 2 and then 3 and then 4, they'll do a ton of math to figure out how many total jumps it would be before they get past 200. But some kid might just start at 150 and then not so much math. Or some kid might decide, well, I don't know, do we have to use all 4 jumps, they might ask me, and lots of different decisions will be made, lots of different conversations. So if a kid decided he didn't have to use all 4 jumps, that just meant there could be 4 jumps. He might start at 190, 193, 195, so different kinds of kids will approach the question different ways. They're all practicing addition. They're all practicing pattern work, and they're all doing good math. Here's another question. This is a fraction. I probably should have put the bottom thing in brackets. I didn't. So there's a numerator, which I didn't tell you. And whatever that numerator is, the denominator is 3 more than the numerator. So I probably, with a bunch of kids, say, so give me an example of what it could be. So I'd hope kids could tell me, well, it could be 10 over 13. Or it could be 2 over 5. I might say, give me an example of what it could not be. So it could not be 4 over 3 because that doesn't work. So we make sure kids understand the question. And then we say, which of these statements could be true and which couldn't? Could the fraction be less than a half? Could the fraction be more than a half? Could it be more than 3/4? Could it be more than 9/10? Could it be less than 1/8? So let's look at the first one, just the first one. Could it be less than a half? What do you think?
Karen says yes.
Perfect. And what would make it less than a half, I won't bother you, Karen, but essentially I'm betting Karen thought of 1 over 4. But she might have thought of 0 over 3, and she might have thought of 2 over 5, but then that's it. No more possibles. So it looks like maybe there's more possibles for greater than, so then we could investigate that. Now, it turns out that there are more possibles for greater than a half, but notice that I kept pushing you higher. Could it go greater than 3/4? And the answer, by the way, is yes. And could it go greater than 9/10? And the answer, by the way, is yes. And it turns out it can go as close to 1 as you want, but it'll never get to 1. So here's an example. 1 million over 1,000,003 is super close to 1, but less. So do you get that you can treat it in a sophisticated way or you can treat it in a less sophisticated way, but you're still doing fraction work, you're still comparing fractions, and you're doing lots of good stuff. Here's a different fraction. This time, I tell you the denominator is between 20 and 30. So it could be like 21, or it could be 25, or it could be 29. And likely a kid will say to me, could it be 20 or could it be 30? And I'd probably say, you decide. Then I say the fraction has to be close to, but not dead on 3/4. So it's got to be close to 3/4, but not quite. So what could the numerator and denominator be? So by the way, folks, I am trying to do questions from primary, questions all the way up to grade 8. So what do you think the numerator and denominator could be if it's close to, but not exactly 3/4? Somebody give me an idea.
Dwayne says 15 over 21.
Beautiful. 15 over 21.
Peter, 8 over 21.
8 over 21.
And followed by a whoops.
Okay. That's great, Peter. Okay, don't worry about that. All right, let's just do the 15 over 21. What I'm betting Peter did, or whoever gave me that question, was that he was thinking 15 over 20 and then just said, yeah, but you can't have it right exact, so I'll change the denominator. So that leads to a great big discussion. Well, could he have changed the numerator? Should he have changed the denominator? Are both always possible? Like, which one did you do? What if I didn't let you use the 20? What other number would you pick? And it could lead to, again, a whole lot of fraction work. Honestly, this question could take up a whole period if you do it right. And but it leaves room for lots of kids to talk, and it deals with important ideas. Here's an algebra question. Make 3 or more equations that include all the numbers and symbols that I have there. You can stick in extra numbers, you can stick in extra symbols, but then you have to give me, I call it a story or a word problem or whatever you use that represents one of your equations. So notice there has to be a 2, a 4, the variable a division sign, and there could be more stuff. So I just did a couple for you just to get you started. Look at my first one. You can see there's a 2, an a 4, and a division. And I said 2a divided by 4 equals 3a. What could a be? Now it turns out that if 2a divided by 4 is 3a, 2a must equal 12a. And when does that happen? And I have a feeling it happens when a is 0. So I did an equation that has a solution of 0. But look at my second equation. 2a divided by 4 equals a divided by 2. So I still have the 2a, the divided, and the 4. And it turns out that there are a zillion answers to that question, or a zillion solutions, because a could be 3 or 4 or 5 or 7 or 2.5 or 18 or -9, because I wrote the same expression 2 different ways. 2a divided by 4 is exactly the same as a divided by 2. Did I say that right? When, yeah, it's exactly this. Oh, I lied again. Did I lie to you again? I should have put in 2 brackets, a divided by 2. I'll fix that again. I did this too fast. All right. Look at the next one. It's just a division fact. A has to be 4. Look at my fourth one. I stuck in another variable. So now the question is, could you pick 2 values, a and b, to make that equation true? And then I switched the 2 and the 4 to the opposite direction. So there's lots and lots of stuff you can do. What I'm trying to bring out is that there are different kinds of equations, and we could play around with all of them.
I'm sorry, Marian. Just based on that question, there a question has come up in the chat box there. Angeline has asked, could Marian speak a little bit about these beautiful questions and how they fit into the math workshop model? Sometimes these conversations take the whole math time, which is great, but I'm wondering how others and Marian might use questioning like this within the boundaries of time to teach, time to practice, and time to reflect.
I will definitely do that. All right. So I'm not sure. I think the math workshop model is used by some teachers. It's not all. So I am just going to talk more generally about the notion that I see the kinds of questions I'm asking you here as the main problem that a kid would work on in a lesson that is a concept-based lesson. So I would envision any one of these being part of what many of us call 3-part lessons, where I have some little activity to get us warmed up. This is the main activity. All of the kinds of questions that I'm asking you now would consolidate that learning from that activity. And that's, and there might be a little bit of practice at the end, but probably not. And that would be a different kind of a lesson than a lesson where I want to definitely make sure I include practice. So when the materials that I've been writing have been focused on the fact that I want different kinds of lessons to happen in a math classroom. There are some days where I want to sort of teach a new idea. And I would use one of these lessons probably to do that, to teach a new idea. And I would not worry about practice and the need for that in that lesson. And I would probably be having kids working in groups, and I'd be circulating, and I'd probably be pulling it all together with the entire class. There would be other days where I might have more practice activities going on, and I would play the game, the lesson quite differently. So, for example, the which one doesn't belong, this lesson, the question I just showed you, I would do that way. The which one doesn't belong question that I gave you a little while ago, for me would be more like a warm-up question, not a full lesson. And so that might be something I talk with either small groups with or the whole class with. I know it could go the whole lesson, but I just wouldn't let it. I would just say to myself, this question is great, but it's not worth all that time. So I'm going to cut it off now and then move to something else I want to do. Does that answer the question of the person who asked me?
I'll wait for that person. She says yes, thank you. Just a couple of follow-ups, Marian, just to kind of that go along with that.
Okay.
Corey says, I have used these types of questions for guided math and math stations. Robin says, I could also see doing this as a critical thinking day or using math journals. And Joanna offers, I have used questions like these for mental math.
Beautiful. And I think all of those are possible. And I think there's probably other possibilities as well. In the world in which I live, because I get to do kind of whatever I want, I'm lucky. I use these questions frequently, that it seems to me that I would want critical thinking to happen lots of days. It seems to me that I'd want mental math to happen lots of days. So I might use them in a lot of different ways. And all of those ways make perfect sense to me. So I don't want to suggest it has to be one way or another, but I will emphasize one of the things I did say, which is that as teachers, we do control the environment. And even though a question could take forever, we have to decide, but it's not going to. I'm stopping it now. And you have to make those decisions all the time. Is this conversation really worth abandoning the rest of my plan or not? And I think sometimes we just let it go because we want to be kind to kids, but I'm not sure we should always do that. I'm sure we should sometimes do that. So let's go from there, and I'll come back to this toward the end. I'm just going to show, we're getting close to the end, so I'm going to show you a few more questions, then we'll talk about some issues, and then I'll address any questions you have. Here's a question a grade 6 teacher might use about prime numbers and composite numbers. Here's a hundreds chart. Could you find 5 composites in a row? So do you see you can't use 1, 2, 3, 4, 5 because 3 is a prime and 5 is a prime and 2 is a prime. Could you use, so kids have to look through the chart and find 5 composites in a row. And it turns out there's a lot of answers. So do you notice here, I found you composites in a row. And it's helping kids identify the prime numbers. So notice 24, 25, 26, 27, 28 are between 23 and 29 because both of those were primes and I couldn't include them. So there's that kind of stuff. Then I might go to, can you find 6 in a row? And it turns out that's way harder because remember when I did the 5 in the row, like 24, 28 were between 2 primes and 48 to 52 are between 2 primes. So you're starting to think, well, maybe you can't find 6 in a row. And then it turns out, well, yeah, you can, but you have to go like way lower. And so that could lead to a nice big discussion. Here's a percent question because I don't want to abandon our higher grade teachers here. Pick a number, call it A. That number A is 10% of some other number. It's 25% of a third number. It's 50% of a fourth number. What could the A, B, and A, B, C, and D be? So kids have latitude to choose their number. So they could decide to call A 10, and then they'd have to figure out what it's 10% of, what it's 25% of, what it's 50% of. So it goes like that. I would say which is biggest, A, B, C, or D, and how many D's does it take to make a C? How many D's does it make up to take a B? And there's a whole whack of math buried in here. I gave you one sample answer on the slides, except there it is. It's not showing. Where did it go? The sample, I thought I had a sample answer for you, but it went away. One of them could be that if A were 10, it's 10% of 100. It's 25% of 40. It's 50% of 20. Notice that 2 20s make a 40. 5 20s make 100. So there's lots of relationship stuff between percents, fractions, and so on going on there. Here's a question involving negative numbers, integers. Choose 2 integers, add them, subtract them. One answer is 4 times as big as another. What could A and B be? So I'm going to talk to you just a brief minute about the question in light of the conversation we had before. For me, I would not use this question as teaching kids how to add and subtract, because they already have to know how to do that to do this question. I'm actually going to treat this question as a practice question, because what kids are going to do is they're going to randomly try some integers until something good happens. And they're going to try some more, because I don't want just one answer. I want a bunch of answers. And what's going to happen is some kids will just get some answers that work, and they will have practiced addition of integers and subtraction of integers. But there will be some high flyers who will want to know, like, how does it work? Like, how could I have predicted which ones work? And they will get even more out of the question. And I'm giving you some possible answers here. It turns out -5 and 3 work. So do 10 and 6. And you might even notice 5, 3, 10, 6, like both the 10 and the 6 are double the 5 and the 3. So like, why did that happen? So you can see that some kids who are curious can go tons of places with this. Some kids will want to know why I had a negative sign in one of them, but not the other one. Lots and lots of conversation. Even though this was meant to be a practice question, like, why not build ideas into it too? Here's a different question. The solution to 5 different equations is 3. At least one equation has n on both sides. What could the equation be? So lots of practice in that one. Here's a percent question. I went to a store. Something was $40, but it was marked with a certain percent off. Something else was $50, but it was marked with a certain percent off. But I saved the same amount on both. How could that happen? So kids are doing percent questions. So again, I'm not teaching them how to do the question. I'm letting them play around with the question. And it turns out, by the way, that one answer is that 50% off of $40 turns out to be exactly the same as 40% off of $50. I wonder why that happened, and that could lead to further discussions. Here, last one I think I'm going to show you here. The area of a circle is about half the area of a triangle. What could the dimensions of each shape be? Explain your thinking, and I've given you some answers you don't have to worry about now. Here's something with exponents that you can look at later. So let me just say a couple things because time is flying. There are some things also that I work with that are called parallel tasks, where kids are given a choice of which question they want to do. The questions are related. One is, I'm going to call it simpler than the other, but the ideas behind them are the same. And this is another way in a virtual or real environment to meet the needs of 2 sets of kids. So here's an example. Choose a price. Show the price in 3 ways. Use 5 coins. Use more than 5. Use less than 5. The reason it's a parallel task is kids can pick whichever one they want. So I'm not saying everybody has to do 46 or everybody has to do 90. It's like, do what makes you happy. All of you are going to be thinking about the same ideas, but you're going to do it in a comfort zone. And I think that's important. I think in a virtual environment, kids being comfortable is unusually important because the learning is so strange for them anyway. Here's another one. This is a problem in one of the resources I've done. The students in Malik's class are each paying $29 for a field trip. So far, 17 kids have paid how much money? So I'm I'm multiplying 29 by 17, but not every kid in my room, even if they are in grade 5, is ready to multiply 29 by 17. So I just changed the number for some kids. Like, who cares? Let them do what they need at the time that they need it. Here's one for older kids. Choose 3 of these numbers. Try to create squares with those areas and estimate the square root. So for those of you who teach a higher grade, you'll notice that 49 has a nice square root, 36 has a nice square root. The other numbers have not nice square roots. That's why I asked them to choose 3 numbers, but they don't have to take 3 awful ones. So that's where you also have some latitude. So I'm going to end by talking about the virtual environment one more time and then entertain any questions you have. I think that in the world we're living in, if you're doing things online, you can't ask for too much at one time. I don't think kids can handle it. So I think that we have to be judicious, pick something that has a lot of richness to it, but don't give them 10 things to do. I just don't think it works. Guard against topics parents might not be able to support, especially with the little ones. So if you have topics where the parent is going to panic when they even see the question, it's probably not the best idea to use in a virtual environment, because the kids are going to depend on their parents to help. And I've actually written some stuff recently about how you can actually support parents by teaching them how to ask probing questions instead of showing their kids what to do. And that's a whole other discussion. Try to ensure interactivity when you're online with them. There's got to be lots of conversation. Maybe buddy them up so that kids are online with each other sometimes. Maybe it's that they respond to you using something like Flipgrid where they talk to you, but there's got to be interactivity. Being positive matters. We're all in a very fragile world right now, and it's pretty tough on kids, and I think our need to be positive is greater than ever. I think we have to ask for not too much submitted work. And as I mentioned, something like Flipgrid that's oral is better for me. And again, having kids still find ways to work with each other. I mentioned teaching parents how to help by asking them, by showing them how we ask questions to kids to prod them along without giving away. So when I had the which one doesn't belong, parents are just going to want to tell the kids which one they would pick. So we have to teach them. Why don't you suggest to your kid to look at whether the numbers are even or odd? Or why don't you suggest to your kid to look at what the answers are? So we give them the kinds of questions to ask rather than show the kids what to do. It's helpful to inform parents of what we're going to be doing with the kids for a period of time if we end up back to hybrid teaching, providing a schedule, and so on. Focusing on big stuff is all that we should be doing, I think, if we end up back in a virtual environment. Now, I'm just telling you that a lot of the resources I used today drew from some books so that you can find them later if you're looking. And now I'm going to stop presenting and ask you if you have any questions that you still want to ask me, because I'm up for it.
It might be easier for people to come on microphone, but there's been one question in the chat box. Someone asked if it would be passed along when you stopped. Peter asks, will the slideshow be on the slide deck?
Yes. So I will be submitting it after I clean up those little mistakes I made today.
Hi, Marian.
Hi.
This is Andrea Small. I used Math Up for an optional math club during at-home learning, and it worked really well because it was a small group of kids. Would you say that the Math Up questions could be used in a whole class environment where you have one teacher and I mean, ideally most of your class logged on at the same time? Or would you say stick with small group?
No, it was intended for large group, and it's being used that way here in Ontario. I'm in Ottawa right now a lot. If it's in a virtual environment, I think I would I would kind of switch it up. So I think that I might sometimes do parts of it where kids work offline and then we come back online and talk, probably then in smaller groups. If it was in a classroom, I would see it as large group, but if it's online, I think there's pieces that could be large group, but some pieces would work better for conversational purposes with smaller groups. One of the things that I mentioned in the beginning was how important it is to use this opportunity to help parents see better what our curriculum is really all about, that we still are doing some of the traditional math that they're used to doing, but we're doing things so that kids understand what they're doing. And that's why I feel it's so important, if we end up going back to hybrid learning or virtual learning, that we help parents see it in a positive way rather than in a negative way. I know my own daughter is working at home and has little ones at home, and life is tough when you have that. So it's just about us finding ways to reach the kids without overwhelming the parents. Thank you, Jacqueline. And Diana, and Leslie, and all of you very nice teachers who are always so generous and say thank you.